Okay. How are you doing, guys? Flew a long way to get here. Hang on, let me just full screen this. All right. So we are here to talk about something really important, code splitting. Hands up in the audience if you know what code splitting is. All right, that's a significant chunk of you. How many of you do it with every app that you put out? Not so many of you. So code splitting has always seemed, before we jump into what it is, has always seemed like something that's a bit historic, something that, let me just ship my web app, and then 6 months down the line, I'll think about it. But I'm here to tell you that code splitting is actually really easy. And the combination of modern tools, modern infrastructure, evergreen browsers, and React itself make it really easy for us to do code splitting. Why should you code split? So here's what we think as JavaScript developers. We work on the fastest ISP known to man, localhost 3000. And this is how we think we ship our JavaScript. Imagine each person is a JavaScript module. Everyone's sitting really nicely together. You're on a lovely little train, which is your network connection. But reality often ends up like this. And it's just a giant mess of a lot of JavaScript, right? And every one of us has faced this before. How do we tackle this? And why are we trying to answer this question now? I mean, as Justin Trudeau said, maybe, it's 2017. It's about time we tackle this, right? And we live in a mobile-first world. And what does that mean? So these are stats that I've pulled up from our own product. And this isn't even a mobile majority. It's overwhelmingly mobile-first. We're currently at 75% of our traffic coming from mobile, and probably by the end of the year, we're going to hit 80, 85%, and this is back in India, right? A couple of years from now, we're not even going to be talking about mobile first. We're just going to be talking about mobile only. So it's about time that everyone gets on board for code splitting and realize that we live in a mobile-first world. And as a consequence of living in a mobile-first world, we have evergreen browsers that auto-update in the background, because of which a lot of the really cool tech that's in terms of infrastructure that's happening, like link preloading, like HTTP2, is already there for a majority of your users. There's no reason for you to hold back saying that, I'll do this later. And most of all, and this is what I want to stress on really in today's talk, because it's easy, here's how you do it. This is how we ship our JavaScript. We send a giant JavaScript file down. Everything looks easy peasy. But there's a couple of problems with this. The first is that a lot of our JavaScript doesn't change very often. Every time you update a single string somewhere and you ask the user to re-download all of your JavaScript, you're asking him to re-download all of React as well, all of React DOM as well, all of Redux as well, all of React Router as well. But why should he? There's no reason to. So the first thing that you got to do if you're thinking about code splitting is think about long-term caching. Take all the parts of your bundle, which don't change that often, which more often than not end up being third-party libraries or frameworks that you use, and just keep them aside. Send 2 files down. We no longer live in an HTTP 1 world where we have to worry about network connections, and we have to worry that we need to send everything down in one go. You can send 2 files down. It's perfectly OK. And your vendor file can be cached forever. By forever, I mean put a hash in the file name, right? As long as it doesn't change, the user doesn't need to re-download it. You change your components, change your reducers, change anything else, he's not re-downloading React. And that makes a huge difference in terms of the second time the user visits your site, they're not going to have to re-download so much stuff. Cache it forever at the CDN level in the browser, and you're good to go. But how about we take this one step further, and we say, that application JavaScript that we were sending down, what if we break that apart? And this is where the real power of code splitting comes in. If I'm on the login screen, imagine you're building a business dashboard. I can't even see the dashboard till I'm logged in. The way that most of us end up building it is I arrive on the login page, but I already have all the JavaScript for the entire application. Even though I'm on the login page, you don't even know if I'm actually a valid user. You don't even know if I'll get to see the dashboard, but you're asking me to pay the price of downloading that, parsing that, and doing all of that work on a mobile phone, which is 5 times slower than your desktop. Why? So one of the easiest and most obvious things to do then is start splitting our application code itself. Send only the minimum amount of JavaScript required. That's it. Whatever it takes to show the user what you want him to see on the current screen, just send that down the wire. How do we do this? So for the first time in a really long time, with ES6, we finally have built-in modules. There's no more 100 different module systems. And now, we also have built-in asynchronous loading of modules. It's a first-class citizen of the language itself. So before, this is what we do. We've played around with System.js, we've played around with Require. A lot of people invented their own ways of using modules. And honestly, this was a mess. And now everyone's gotten on board the ES module train. We love this. This is so easy. Everyone does this. And now there's an extension that's recently been added to the language itself called dynamic import, which is the last line over there. And that loads modules asynchronously. So it's currently in stage 3, which means that more or less all the key stakeholders have agreed on what it looks like, and browsers are starting to implement how it works. It's available today in Webpack 2. All the other sort of module bundlers will also start having support for it. It returns a promise because it's asynchronous in nature. It can accept dynamic module names, so you can pass it a template literal string and load something based on some JavaScript that you execute. And it's available today using that Babel plugin. This is not near future. This is now. You can use this right away. Here's a simple example of how that works. We have two really simple modules, A and B, each do a simple console.log. And then we have our index, which loads asynchronously, so it's bundled together, but B is loaded asynchronously. And then because it's a promise, when that promise resolves, we have access to the module, right? We run Webpack on this. I'm using Webpack because that's the one which has support right now. And shout out to the Webpack team for having such an easy API. We just run a simple Webpack on it. Webpack spits out 2 files automatically. That's it. You have your main file which synchronously loads stuff, and that asynchronous file, the JavaScript that you were loading, is created in a separate file. You don't need to load all that JavaScript. You just load the synchronous part of it in a script tag in your head. But what happens when you actually load this in your browser? Since import isn't available, or dynamic import isn't available in browsers yet, Webpack polyfills that and adds an asynchronous script tag to the head. That's it. It'll lazy load. Browsers will asynchronously load that. It's not render blocking anymore. As you can see, you can look at the network waterfall. It loaded later. And you can look at the console. You can look at the log to see both A and B were loaded. And this is available right now. It's really that easy, right? The first time I figured this out, it blew my mind. I was like, oh, my God. Right? Yeah, Team Sam. Now, coming to how we can use this in React. So whatever I said right now is sort of more generic. But the power of React, where we're treating UI as a function of state and we're using functional programming paradigms, lend to some pretty powerful things that you can do with code splitting. So in React itself, components can be functions. I mean, we love our stateless functional components. They can be classes, which is how most of us write. But they can't be promises. Not yet, anyway. With Fiber, that's definitely something that's on the horizon. In fact, I think there's a PR open adding support for promises as first-class citizens for components. But today, you can't do this. And if you think about it, an asynchronously loaded component, you'll want to add your own logic there. As Sebastian said in his keynote yesterday, the way you load it, the loading steps, are something that you want to define. Your user experience guy will tell you that this is how we do this, right? Maybe you want to show a shell. Maybe you have a really fancy loading indicator. Maybe you do something like a Slack where you display a really happy message to someone. But there's something that you want to do even before the component loads. So you want to be in control of how do I load these components, and what do I do when my component hasn't yet loaded. And React, because of its state management, makes it really easy for us to be able to do this. Let's take a look how. So here's a really naive implementation of what a lazy loaded component will look like. Don't treat this as production ready, but it'll do the job. We just treat the fact whether the module has loaded itself or not as state. That's it. Because in React, once you start treating things as state and your UI is a function of that, this lends itself to lazy loaded components really well. When my lazy loaded component mounts, it fetches the component that's associated with it, sets it to state, my render function's called, which will either have a loader displayed when when the component hasn't loaded yet, or it actually shows the component. That's it. This is all you need to lazy load in React. Nothing else. There's a ton of edge cases that we might go through, but at the core of it, this is what it looks like. And if you think about this, this is a pattern that's really familiar to all of us. Why? Because it looks like how you'd make an API call. This is exactly what you'd do if you had a component that had a dependency on some data. So on its will mount or did mount, you'd make an API call, fetch the data. Till then, you'd show a loader. Loading components versus loading data is the same thing. In JavaScript, functions, components are first-class citizens. There's no difference. And this is how you'd use it. You'd create a simple functional component. Whenever that get component is called, your lazy loaded component is loaded. So what kind of patterns does this open up for us? So a few things that you need to be aware of when you're using this with React. You can use higher order components to sort of decorate that this is a lazy loaded component. Pretty straightforward, just like how you'd use it for data fetching. You'd have to figure out caching, which is so that you don't have jank in there. You can cache it in a store, just like how you'd do with data. You can cache it as a static on the component itself. You can write wrappers that lazy load children in parallel. You can have independent components that say, hey, I'm lazy loaded, hey, I'm lazy loaded. But for a better user experience, you could wrap them all up in something that downloads all of them in parallel. The thing is, when you start thinking of lazy loaded components or components itself as data dependencies, all these patterns start getting unlocked. So async modules are promises. Treat them how you would like any other data. When resolved, they return the component, and then you can do whatever you want with the component. Now, the next question that comes to mind is, where should I code split? So we know that we need to do it. We know how to do it, but where should I code split? Route level splitting. This is probably the most intuitive one. I mean, everyone sort of gets it immediately. It's almost always the best place to start. But this only works if your routes are very distinct from each other, right? It's also where you can have the maximum size reduction in your output bundle, because if you have two views which are very distinct, again, I take the example of a login view and then your actual dashboard. There's not a lot of code duplication going on over there. They're very distinct from each other. One loads all your fancy frameworks. The other is just a simple HTML form. So you can have a lot of size reduction over there. Your router needs to be async aware. If your router itself is not async aware, it needs to expose the right kind of abstractions for you to be able to do this. You need to be very careful of code duplication in your output. We're going to talk a little bit of how to avoid that as well. But if you go crazy on the route level splitting and you say, you know what, my app has 20 routes or 20 different endpoints, I'm going to code split all of them, right? And then you spit out a distinct file for each of those. What you find out is, a lot of them have a lot of code in common. So you have to be very careful that you avoid the problem of code duplication. And a lot of us end up structuring our React apps in sort of, here are our dumb components, and here are our smart containers that know how to do this. And what you find is if you split a lot at the route level, a lot of these components are reused across a lot of the routes. So you end up having code duplication where the same base set of components are there in every file. So you have to be very careful to make sure that doesn't happen. So here's a really simple example, right? I have a login screen, I have a filter screen, I have a view screen. There's very little in common between the three. So this is an ideal use case for somewhere where you'd code split. Here's a simple example with React Router v3. The reason I'm using v3 and not v4 is because, when I was preparing the slide, v4 wasn't out yet. And a lot of you, how many of you are using React Router v3 in production right now? OK, that's a huge chunk of you. So changing the fact where you were synchronously passing a prop, which is the component that needs to be matched, changing that to use the get component callback instead is all you need to do to have asynchronous code splitting done at the route level right now. That's it. So even before, if you're thinking about migrating to V4, how do I do this? In V3 itself, this is the easiest way for you to switch, and you can do this today. With V4, because it's become a lot more components itself, with V4 it's a lot more simpler. You can build your own abstractions, you can build your own sort of custom logic on top to asynchronously load stuff. So you split at top level routes. Each async route gets spit out as a distinct output file, which is why you need to be careful of code splitting. And then whenever the route is matched, you fetch the component, parse it, load it, and it's visible to your users. But the real power of React, right, and the real power of the combination of React with code splitting is when you take code splitting to the component level, right? This is analogous to writing smart and dumb components. You have your dumb components, which is just UI, or you have your smart components, which do things like make API calls, they're connected to your store. So think about dumb components in the same manner as dumb components are displaying your UI. They have smarter cousins that figure out when to lazy load them. Should I lazy load them, right? The lower down the component tree that you move, the greater the flexibility that you get, and the more the kind of patterns that you unlock with this. And this is the part that I really want to stress on, which I hope you take away from today, is it enables useful conditional patterns. And this is a really, really powerful abstraction that you get with React's model as well as code splitting, which is you can conditionally load stuff. Let's take a look at some of the stuff that happens because of this. So new buzzword alert. I mean, Tom tells me that this might become a buzzword, but we've been experimenting with something called responsive components on Insider.in, and we're doing it a fair amount. So in today's day and age, when you're building out something new, this is sort of the methodology that we all follow. You'll do your mobile-first design. You'll write your CSS mobile-first. But your JavaScript isn't really mobile-first. Your JavaScript is still the same monolithic bundle that you run on your desktop and then ship to your users who are using it on a phone. And we can change that. Imagine a very common use case like this, right? I mean, everyone has seen something like this. This is pulled off our production site, where you have a hamburger icon that opens a menu bar on mobile. The same thing on desktop gets pinned to the top. This is how it looks like, right? How do you model something like this in your component hierarchy, right? Do you do one component with all the markup and then use CSS to mess around with that and say, hang on, let me do this? Do you do two components? You call one mobile header.js, you call the other desktop header.js, and then on the client side, you figure out which one to load. But that leads to a subpar user experience, right? Remember what we said. We want to figure out how to do mobile-first JavaScript. So what we do instead is we always load the mobile JavaScript, the mobile header, and gracefully upgrade to the desktop one. And how can we do this? Because we have lazy loading, right? This is as simple as you loading a component that checks something on the client side and then lazy loads another component and displays that. That's it. And this is one of my favorite examples. So when you were building this sort of carousel out, and then I was trying to wrap my head around sort of how to get this working on desktop and mobile, the designer in the team was just like, why do you need JavaScript for this? And then I took a step back and I realized, actually, hang on, I don't. How many of us have built carousels on our React apps which have used either our own carousel plugin or a third-party node module? Can I get a show of hands? Right? But the truth is, if you're building a carousel on a mobile, you don't need JavaScript. It's just a horizontal div that overflows, right? Why are you shipping JavaScript down to your 75% of your users, which isn't going to be used? But the same carousel on desktop needs JavaScript. You need to handle the little clicks on the arrows. Someone might be opening it on an Ultrabook, and they might have touch enabled, so you need to figure out how to respond to touch events. So you need to be really smart about that and build your components in a mobile-first way, and then gracefully upgrade them to their desktop versions or to other feature-rich versions using lazy load. This also applies to things like A/B tests, to feature tests, where you send something down the wire, and then on the client, you dynamically load other things. And conditional imports are really easy, right? If you treat them just like how you would any other data, it's just saying, if this condition matches, render this component, which is lazy loaded. Otherwise, render my default component that I ship down the line, right? So there's a few gotchas that we need to be careful of when we're dealing with this. The first is server-side rendering is really tricky with this. The reason I say it's really tricky is because on the server, you will end up synchronously requiring all of these dependencies, right? But the JavaScript that you'll be shipping down to your users will end up asynchronously loading it. And what happens? Because React, when it starts up, eagerly attaches itself to the entire tree, you end up getting this infamous error, right? The mismatch in markup error. So you have to be really careful that you make sure that your server and client are always in sync when you're lazy loading. Always profile on real devices. This is really, really important. Again, as I said, as developers, we tend to test on the fastest ISP that we know. Test on real devices. Putting some sort of slowdown on your dev tools is still not good enough. There's tons of great ways to do this. Happy to talk to you guys offline about how you can use analytics, for example, to figure out how much time your actual users on mobile devices are taking to load all of this. But always profile on real devices. Avoid network waterfalls. And this is actually really important. You might get carried away with code splitting and say, hang on, I'm going to code split at the route level. So my route's going to lazy load. But my route itself loads 5 components, 3 of which are lazy loaded. And then those components load something else, which is, again, lazy loaded, because every single developer in your team is like, this is amazing. I'm going to lazy load across the board. And then you have this mess of a waterfall where it takes a really long time for your app to actually be interactive, right? So how do you avoid this? A, by making sure you don't go crazy on the lazy loading. The other is something known as resource optimizations that browsers give you, which is the link preload and the link prefetch tag, which basically tell the browser that even before you've downloaded the first JavaScript, which we know will, at some point of time, lazy load the second JavaScript, why don't you keep the second JavaScript downloaded and keep it with you, just in case, right? And this is widely supported in most browsers today. So you can give hints to the browser saying that my code, while it's loading this, might also load these other things. So you might want to cache them and keep them ready. And this can really help with waterfall issues. Now, this is actually really, really tricky. And I'm actually not going to spend too much time talking on it. But the key thing to note here is dynamic imports are always asynchronous. As I said before, dynamic imports return a promise. And a promise, by its nature, will always resolve asynchronously. So if you have a situation where you were really smart about how you were prefetching or pre-downloading, or you were using HTTP server push, and you have a lazy loaded component, but it's already been sent down the wire. The browser's already cached it. It's there. It's available. You should be able to use it right away. You can't. Because it's returned to you as a promise, for at least one tick of the CPU cycle, it's not going to be available to you. This is a very fundamental issue. I don't know the solution. A lot of people have been thinking about it. But this is one way where there's a lot of community effort that we need to do to figure out how to do this. And lastly, this is what I want to end on for all of you. And this is the key takeaway that I think all of you should take away. If you can write a component that makes an API call, you can write a component that is lazy loaded. It's that easy. Go ahead, get started with it. Make your mobile users happy. Thank you.